So we're checking our Algebra 2 skills really quickly. Now, the instruction is saying evaluate the logarithms. And we did spend one concept categories to learn about exponential equation and logarithm equation last year. And if you kind of forgot how to do this, and then I will give you the heads up here, okay? So the method that I usually use is I set log base 10 of 1,000 equal to x. Then I will convert this into exponential equations. Then I can find the x here. I can find the x here. Okay. Then what's gonna be the base of this exponential equivalence? Anybody know? What's the base of the logarithm that we have?
10.
10, yes. So now this is gonna be base 10, then raise of power of what now?
X.
X, yes. And then it's equal to?
1,000.
1,000, yes. Then what exponent raise 10 into 1,000?
3.
3, yes! 3, Molana, yeah. I taught you last year, okay? Then what's x? X is 3, then you can write it. Three here. So we evaluated. So evaluating logarithm expressions, it has the way behind you convert it into the equivalent exponential expression, and it gives you the idea what x variable is supposed to be. So then let's do quickly b. Then I will set log base 2 of 32 into x. Then now, again, what is the base?
32.
Yes, 2. Then 2 gets what? Power of x is equal to what now? 32. 5. X is 5. Okay, then I will do C and D really quickly. But when you rewatch this video, pause the video and then try out and then check your answer again. And log base 10 of 0.1, base 10 raised to the power of x is equal to 0.1. And 0.1 is equivalent to 1 over 10. Then 1 over 10 can be rewritten as 10 to the power of something. Let's see if there's someone that knows this.
1/2.
Half, almost.
-1.
-1, yes, -1. This is negative power property, right? So then what is x? X is -1. So evaluation of this is -1. Okay, quickly, next one. Then 16 to the power of x is 4. Okay, then now, the problem is we don't have the same base in this equation. We have to rewrite bases as the same platform. But good news is 16 is multiple of 4. It's actually 4 to the power of 2. Then what's x? It's right there.
1.
1/2.
Yeah, it's 1/2. Okay, so then now I can rewrite it. So it's 16 will be square root of 16 is 4. So then 16 raised the power of 1/2 is actually the same thing, square root of 16. Then that's equal with 4. Then this x is supposed to be 1/2. That's why log base 16 raised the power, log of 16 of 4 is 1/2. Okay, and now once we go next slides, then it will show all the work there. Okay, then there's an answer for you to try later. Okay, then next one. Then now, what we are looking at together is the graph. Then first one is basics of exponential function. Then same manner, only difference is base of the first exponential function is a whole number. And the base of the second function, g of x, is a fraction. Then either way, you can utilize graphing program, decimals. I love decimals. So from now on, I think you have to get used to using decimals and go ahead and try. And it's very easy. Everybody can see how to use it. But if you don't, let me know by email and then I will give you easy instruction on that. So just always try the decimals to graph out, and then it's gonna give you a big enlightenment how you can indicate the shape of graphs and key features very quickly. And it will help you guys big time to do depth of knowledge assignment later. So then, since we don't have that much of time, I will show you the illustration right away. So either you graph it with devices in the programs, or you can actually plug all this one by one and plot, and you graph, you will see this. So as you see, whole number base, the exponential graph is increasing as we go to the right. And base being fraction gives you exponential function decreasing as we move to the right. So then we call this one decay, and we call this one growth. It's exponential growth and exponential decay. What determines your graph increasing or decreasing is the base being whole number or fraction. Yes. Okay. Are we all good? Okay, I'm moving on. Oh, isn't that cute? You know what? When I was teaching everyday class in school, in person, and I have agenda every day with cute the gifts, and then people come in my classroom and just watch it, and sometimes it's like really funny, and then they just laugh, and then like we just start the topics, and then conversation, and I miss those days. Oh, we don't have time to chit chat. So guys, feel free to stop me if I get sidetracked, okay? All right, then now, I know this is a lot, but read carefully one by one in your own time, but I will briefly explain what is it on this page. So you just saw the graph of exponential functions, and you saw the basic equation of the exponential function. And relate to that, we are also working on logarithmic functions and graph at the same time. And what's the relationship between two functions and graph? Is simply we see them as inverse to each other. This is the key. So logarithmic function is the inverse of exponential function. Then exponential function is the inverse function of the logarithmic function. Then one-to-one in horizontal test, and we can verify they are inverse of each other. Then with function notation, we can see the relation between inverse function is simply you have input and output switched. As you remember from unit 1, we literally switch x and y so that we could have inverse of the given original function by switching input, which is x, and output, which is y. Then equation-wise, that just like we experienced on the very first slide, that you can convert from one to another, this way you can have original function and its inverse as exponential and logarithm separately. This is just simply stated all on this page. So read it carefully, take some time, and contemplate it after. But key word that you have to remember is inverse. Two functions that we are dealing with in Unit 2, they are the relationship of being inverse to each other. It's not one to the other, it's vice versa, okay? And now, next. Okay, then as I said earlier, we can also see the relationship between logarithmic equation and exponential equations by switching input and output from one form to the other. And if 32 is equal to base 2 raised the power of x, then we already saw the answer. The x should be the power of 5. Then if you remember that, now I recognize 32 as output and the power of x as input. So then I can rewrite it as the function notation in here. So you plug 5, and then the 5 is being the exponent. Then the result that get out is the output 32. Then here, inverse function of the output is plugged back in will be the output input of the original as the output of the inverse function. So then in the middle, why it's not moving? In the middle, we have this. Then I can name the result as the inverse function goes by logarithm base 2 of x is the inverse function of this. So now we pair this and this as original function and the inverse function. Okay, then this might be a little bit too much for you guys to process if you don't get this right away. But don't worry. Next slides are giving you some thought bubble. It's throwing you these questions for you guys to go through and then make sense out of it. Then inverse of f of x, which is the exponential function, the inverse, is called logarithmic function that we just saw. But what you can compare is when you have exponential function, if base is b, Butters, I'm teaching a class, yo. Okay, then the b is the base of the exponential function. Then you can see the inverse of the exponential function, which is logarithmic function, also keeps the, okay, I'm sorry, okay. Ugh. Sorry, I'm back. Base is matching as the inverse function of logarithm, but you still take the same base, b, as the base of logarithm. And then now the output of the earlier function is being the input. And then the input of the original function is being output of the function. Okay, this is illustrated into this following slides. Okay. Then, so this is still saying the same thing. Then let's try this. Let's graph f of x is equal to 2 to the power of x and g of x being log base 2 of the x. Then what do you notice between these two functions? What are they in relationship then?
Are they both like 2 exponent x?
Yeah, so they are what for each other?
The inverse.
Exactly. They are the inverse because this is exponent base 2. This is logarithm base 2. Okay, then the graph goes like this. As you remember, the basic exponential function here, I have whole number base and it's gonna be growth. So now I can quickly sketch. It's a really rough sketch. I'm just gonna have this basic curve going up as I move to the right. But what I always do is I just have this quick sketch going up, but make it pass where? 1. This is guaranteed if you don't have any transformation because this means when x is 0, y is 1. Why do you think this happens all the time?
Because a number with a power always is 1.
Yeah, because 2 to the power of 0 is always 1. Great job. Okay, then now the graph of the inverse of this. I don't know if you guys remember this. The graphs of inverse function is reflection over this diagonal line. So now I will graph it. And then I will make the reflection of the original line over the line. And it goes like this. They are exactly mirror image. Then I'm asking this. Then if this was 0, 1, what is this corresponding coordinate here?
1, 0.
1, 0. Yes. Then now you see X and Y truly switched. That's how you see the relationship on exponential and logarithmic function graphically. They are truly inverse to each other. Even graphs are following the conditions to be inverse to each other. Okay, so if you go to next, then it will show you how each graph will be accurately graphed on the program. And then it also comes with the plots. Then you will check if that really works. And you can also ask yourself these questions that are suggested on the next slides. Then this is very important. This is a very important part. So now we already saw the big picture of the relationship between two functions and graphs go, right? Then now I provide key features of each graph. So you can always just go by one, and then you just check your thinking by checking the next page and see all these key features in your time and understand everything. And let me know if you have a question later, okay? So now, here, what time is it? Okay. So I think I cannot deliver everything for this session, but I will do a couple more. Oh, isn't that cute? But I gotta move on. Okay. So then the next page is showing what base E and its inverse, which is log base E. And another name of this is natural log. Then they're nothing different from regular exponential function and the logarithm function, but only difference is they take special values E as their own basis. That's all the difference that you can take from them, okay? Then this is nothing special. And then you can just see here. And this is really, really important. Now, in order to do the practice problems, I strongly recommend you guys to visit this note in this slide that each part of the equation, as you see, how it does the transformation on your graph. So you can read part by part. Then it will help you to figure out the problems on the practice problem assignment, okay? And I hope I can have better lecture on some other classes so that I can upload the video there. Even if it's not, I will make a separate one and then upload it by Friday. And I need you guys to check back later.